Welcome to the AICE Math Review on Derivatives. This is going to be a three-part review, and we are going to go over the power rule, the product rule, and the quotient rule today. So these are the three main, or like the three most basic rules when you're dealing with functions, and it basically says that when you have a constant, let's say a, okay, and you multiply it by x to the n, the derivative of this is going to be a, your constant, or your coefficient, I'm sorry, times n times x to the n minus 1, okay? And this is one of the most basic rules of derivatives, okay? This looks a little intimidating, like what's going on here, but I'm going to display it through several examples and you'll be able to see. So here I have two functions and we are going to evaluate the derivatives of them. They're long, yeah, but the good thing about derivatives is that you can do it one part at a time. So we'll do one of these terms, then this term, then so we do each term individually and then we find the whole answer that way. So it's really good that we can do that. So we have our function, and we have to find the derivative. The notation for a derivative is f prime of x, okay? And the prime, it's not a 1, it's an apostrophe. The prime denotes the derivative of this function, okay? So let's just do it. So what we do first is we multiply the coefficient to the front. So there's like a 1 here, so it's just 5 times, so 5 times x to the, and then we subtract 1 from our exponent, that's 4. Okay, that's it. Now we just add each other term, okay? So then 4 times 2 is 8, and then x to the, subtract 1 from 4, that becomes 3. It's as easy as that, and we just do it for each of these terms. So we have a minus sign here, so 3 times negative 10 is going to give us negative 30x squared. And then plus 2 times 7 plus 14x, and since it's 2 minus 1 is 1, we can just leave it as x. We don't have to put x to the first power, okay? So in here, these last two terms are where it may be a little confusing. But just know that this technically has a 1 at the top, okay? So minus 3x to the first power, we multiply 1 times negative 3, that gives us negative 3, and then we subtract 1 minus 1 is 0, and x to the 0 is 1, so we just leave it as minus 3. So, you know, you could put x to the 0, it's not going to hurt, but it's not necessary. And so how about this constant at the end? What's the derivative of a constant? Well, notice that it's x to the 0. But if you multiply 0 times 179, or any other number, just a number, it's going to give you 0. And this will become x to the negative 1, but it doesn't matter because the entire term is 0. The derivative of a constant is always 0, and that's important to remember. So this is it. This is our equation. That's our entire derivative. It's really not hard. All you have to do is remember that you just multiply the power to the front and then subtract 1, okay? This is where it gets a little more difficult, okay? But if you know how to work with negative exponents and fractional exponents, actually I meant to put a square root here. This is the square root right there, alright? So if you know how to work with negative and fractional exponents, this is going to be fine, okay? I'm going to rewrite g of x in a form that is easier to work with, okay? So this is 10 times x to the negative 1. Why? Because again, this is a 1 here, and when you have an exponent, like x to some number on the bottom, you can move it to the top and have a negative exponent. If you are unfamiliar with that, I would suggest reviewing that on YouTube or something. So then this just becomes minus 2x to the negative 2 plus 33x to the negative 3. And then here, this is interesting. So this term here becomes x to the 9 over 2, right? So because the square root of x is x to the 1/2 power, and then 9, well, it would be 9 divided by 2. Again, if you are unfamiliar with that, I would suggest reviewing that. So this entire term becomes 2x to the negative 9 over 2, okay? So now, g prime of x, the derivative of x, this is, again, what we're doing here. But remember, working with negatives, you're doing the opposite of when you're adding and subtracting, so don't make mistakes. So I'll explain what I mean in a second. So negative 1 times 10 is negative 10 to the x, and this is what I mean. Don't do 0. It's not 0. It's negative 2. It's a mistake that is very easy to make, but it's going to screw up your entire derivative if you mess it up. So make sure you pay attention to what you're doing. Negative 2 times negative 2 becomes positive 4x to the negative 3, not negative 1, negative 3. And then this becomes a negative 99, because negative 3 times 33, x to the negative 4 power. And here, this is a fraction. Again, just do the same thing. This becomes a negative. 9 over 2 times 2 is just 9, x to the negative 11 over 2. And that's it. That's our derivative. And yeah, so that is the power rule. I don't really need to go over anymore because in each one of these we did some practice. So we'll move on to the product rule. Alright, so now we are going to work with the product rule. And here I have u and v, but they are functions of x. They're both functions of x. I just don't want to have to rewrite that all the time. So I'm just using a shortcut, just a little variable substitution. And it says that u times v prime plus v times u prime is our derivative of u times v. Well, what does that mean? That means take our first function, and then we multiply it by the derivative of the second, and then we add that to the second function, and then multiply it by the derivative of the first. It's actually not hard to remember. It's probably one of the these are probably the easiest ones to remember, which is good, because there really aren't that many formulas for derivatives. So yeah, let's just do it. So our f prime of x, so f prime of x is just simply going to be, well, we take the first one, we're already a quarter of the way through our answer, and we multiply by the derivative of this. Well, this is 3, constants are always 0, derivatives constants are always 0. 2x, this is just going to become 2, power rule basically, and then we're going to add that to our second function, 2x plus 3, and then we are going to multiply by the derivative of the first, which is 1. That's it. That's entirely it. You can evaluate that and simplify it and all that, but I'm not going to do that. That's not necessary. Unless your teacher obviously wants you to, then you have to. But, I mean, that's basic algebra. You should know how to do that. So here, oh no, here we have two functions that are more complicated, and we're going to find the derivative of this, okay? We have higher exponents, 3 terms, negative exponents, all that. But it's really not hard, okay? So again, we just write down the first one, 3x to the 6 plus 2x squared plus 3 times the derivative of this. Again, this is just 5 plus, okay, this is just 2x to the negative 2. And the derivative of that, negative 2 times 2 is negative 4, so we're just going to erase that. That becomes negative 4x to the negative 3. Okay, and that's it for that. And we're going to add it to, I'm just going to write it down below here because I don't have space here. Again, we just take this, 5x plus, I like to use negative exponents, but your teacher may not, so 2x to the negative 2 times the derivative of this, not that hard, 6 times 3 is 18, x to the 5th power plus 4x, 2 times 2 is 4, 4x, again, derivative of a constant is 0, that's it, that's our derivative. And that's the power rule, or I'm sorry, the product rule. That is it. You could simplify it again, but I'm not going to do that. That's going to take like a half hour, so I'm not going to do that. But I encourage you to do more practice problems, because you can really come up with any random numbers. These, I just randomly came up with them, and I mean, you know, you can do anything. You can do any combination of numbers, and it's going to work. You can make up your own practice problems. So that's the good thing about these. Our next rule is the quotient rule. This is where we have u divided by v. Again, they're two functions of x, and we take v, the bottom, times the derivative of u, minus u times the derivative of v, divided by v squared, okay? You can remember this as low d high minus high d low, d meaning derivative, divided by low or low squared. There are different ways you can remember that, but yeah. You can also just derive it from the product rule. I'll make a video on that eventually, but yeah, it is derived from the product rule. Basically, it's u times 1 over v, and you can work with that, but we're not going to do that proof today. We are going to actually just use it. So let's just do it. So v, our bottom function, is 3x squared. And by the way, you don't have to worry about actually remembering these, since they're on your AICE formula sheet, so that's why I have these written down here. So 3x squared times the derivative of u, which is just 1, because 1x, 6 goes away basically, plus, minus, you have to, it's not the product rule, so minus x plus 6 times derivative of this, which the 7 is going to go away, so this is just going to become 6x, and that's it to the first power. And then we're going to divide this by 3x squared plus 7 squared, and that's it. Actually, that's our f prime of x. Okay, and so then g prime of x here, our second function that we're going to differentiate. This is more complicated because we have negative and fractional derivatives, and so, but it's really not that hard to work with. Again, this is just, actually, yeah, that's the square root of x. We can leave it like that, but this one is going to turn into 2x to the negative 3 power, okay? So this becomes, okay, so actually let's just do this. So our bottom function, it's going to be x to the 1/2 plus 400 times the derivative of our top function, which is going to be 4x plus 3, since that's just that, and then minus 6x to the negative 4, okay? I don't have enough room here. Okay, I just erased the g prime of x, but you know, it is the derivative, you know that. So then we're going to subtract the u, so this is simply just, wait, no, yeah, this is the top function, yeah, okay, I got a little confused there. This is going to be 2x squared plus 3x plus, again, I like working with these negative exponents then, times the derivative down here. This 400 is going to go away, so x to the 1/2, that's just going to be 1/2 x to the negative 1/2, and then we're going to divide all of that. That's a very good straight line there, and we're going to divide all of that by x to the 1/2 plus 400 squared. I would not bother multiplying everything out, simplifying it all, just leave it like that. Unless, of course, your teacher wants you to do that, but I hope your teacher's not gonna put you through all that pain. But yeah, that's the quotient rule, and that pretty much sums up this video. In the next video, we will discuss the chain rule as well as pretty much all of the other derivatives you have to know. And then in the third episode, we're going to talk about implicit differentiation. So yeah, thanks for watching, and I will see you in the next video. Bye.